Now, a couple of things here. Notice it says code automatically generated. Okay. Just leave that alone. Don't play with it. If you want to change anything, you can just go up to robot, motors, and sensor setup. Now, every robot is given a task. You are going to give it a task to do. So pretty much in this class, we're just going to do a main task. In the future, if you were to join the robotics club or you were to take a robotics class, which I have offered in the past, but I don't currently, I would show you how you can actually write separate tasks, and you can have it do 2 or 3 tasks at the same time. It's pretty cool. Okay, so we're going to do our task main, and we're going to ask ourselves what we want our robot to do. So I'm going to just tell it using what's called a comment. See those 2 forward slashes? Those are on your keyboard next to the shift key. That's for a comment. Anything that follows these slashes will be green, and your robot will ignore it. It's just a comment. You're basically giving yourself some notes. So if I want mine to drive forward for, I don't know, 5 seconds, and then I wanted it to turn to the right. Oh, that's weird. It doesn't tab. I like to tab things over in here. And then I maybe have it turn right, half turn. Okay. What I could do is I could actually just plan my entire program using comments. And on the maze, really, if you think about it, you're going to drive forward, you're going to turn, and then you're going to drive forward, and you might turn to the left, and you might drive forward. So you can actually, in your comments, write everything you want it to do. In fact, this is the better way to program. Okay? But because it's a comment, your robot ignores it. It's for your purpose. And if, for example, the first driving forward, something isn't working right, you have a comment there to indicate, oh, that's what I'm trying to do here. So let me show you how you're going to drive forward. Motor. Look at this. Motor. Bracket. Now, if you're going to drive forward, what you want to do is you want to give it power. The power you give it is between 0 and 100 for forward. 0 means nothing, right? It's just stopped. If you give it 100, it's 100% of the power. Now, my recommendation is you don't go 100%. I would go about 75.
Wait, how fast would that be?
That's 75%. So I'll put a little comment here. 75% power. And then I'm going to do motor. Left.
Will this actually make it do like
equals 75. Okay, 75% power. So if you think about it, if you want it to go straight, in theory, I should say, in theory, you want to give both motors the same amount of power. We're not. Now, the last thing we need to do is tell it how long we're going to give it 75% power. So what you want to do here is wait. And it sounds kind of interesting. So you're going to do wait, and I would do it as wait 1 millisecond. And then how many milliseconds do you want it to go? If you want it to go 1 second, how many milliseconds is that? 100? 1,000. A millisecond is 1,000th of a second. So wait 1 millisecond, 1,000 basically tells it to wait, in other words, to go 1 second. By the way, once you set motors right and left at 75% power, they're just going to, as long as you don't tell it otherwise, it'll keep going. So the moment it sees motor right and motor left at 75, it begins. Okay, the wait 1 millisecond just means keep going for a second. Then we're going to stop it. Motor. And this time to stop it, give it 0 power.
Are there different formations of robots?
Yes, there are different formations. It's up to how you set it up.
No, like how, like,
Okay, watch this. So this is drive forward for 5 seconds. Well, in this case, I said 5 seconds, so what do I have to change on here? I have to change this from 1,000 to 5,000.
What does that do?
Okay, what this does is, all this does is it tells the program to wait for 5 seconds. But because we gave left and right motor 75% power, it's going to be at 75% power for 5 seconds. Then, after we've waited 5 seconds, we give it 0 power. That stops it. So the big question is, how do we run this program? So right now I have the first part of my program. We're going to test it out. So what I want to do is I need to save my program. When you save your program, I want you guys to save your program in your own student folder. Save as. Find your folder in the media drive and save it there. By putting it in the media drive, your partner can access that if they need to. Oops, wrong one. Advanced Tech Lab, student folders. There are team folders you can create later. We'll deal with that later. I go into my folder, and I'm going to call this Maze Challenge.c. Okay, save it as .c because it's a C-level program. You're actually programming. Pretty cool, huh? Now, once you've saved it, notice it says Maze Challenge at the top. Go to Robot, and you're going to compile and download program or type the F5 key. Before you do, turn on your robot. Click Compile and Download Program. It says currently connected is different from previously, blah, blah, blah. Try it again. Okay. All right, guys. Take a look where it says Programming Debug. Click Start. You hear that? There. That was 5 seconds, 75% power on both motors. Now, I'm going to go ahead and stop this. To get done with the debug, you can just close that. At this point, I have uploaded my program to the robot, and I can test it out. So I take it out to the course, and I'm going to press play. I'm going to pause this video for a second. Okay, mine went off the course. I'm going to try to have it go for 3 seconds. Save my changes. Yeah. Replace it. Compile and download program. Do it again. I'm going to click Start. Let it go. Okay, that worked. You notice how it was shorter in time? So I made my change, take it out of the course, and play around with it.